Hi everyone, welcome to the fourth in our sequence of 14 short videos introducing you to satellite Earth observation. In the first three videos, what we did was load up some Sentinel-2 data, and then we've visualized it on the map looking at this area in Manhattan. And in the last video, we showed how the near-infrared data is very, very bright. So it shows up healthy vegetation extremely well. The thing that we want to do now, though, is to say, well, but we have to take into account that there is also some shading here. So in areas where the sunlight is being shaded by the trees, for example, it's a bit lower, the signal isn't so bright, so the near-infrared won't be so bright. So is there a way that we can actually tease out some of the key properties about this bright near-infrared signal and actually quantify it in an index? And that's what we're doing with the normalized difference vegetation index, the NDVI, that many people will have heard of. I'm sure you've probably come across it too. So what actually is it? Well, it's an index which takes the difference between our near-infrared channel and our red channel. So if I used red in two of my bands here and near-infrared, then what I'm looking at in this image is essentially any changes in color are an indication of the relationship between the red band and the near-infrared. And what we kind of want to do is to characterize that in one index. It's a normalized difference vegetation index. That's what the N stands for in NDVI, because we're also going to divide it through by the total brightness. And so what that means is that areas that are bright because they're in the sunshine versus areas that are in the shade, if the ratio between the near-infrared and the red is the same, they're going to have the same NDVI value. And that's what we want to do. We want to get rid of any of the biases due to how much sunlight is hitting the surface. In Earth Blox, we make that relatively easy by having a block which is about adding indices. So when we add an index block in here, it automatically knows what kind of data you're looking at. So if you're looking at radar data, for example, it will give you a different set of indices to look at. We can also categorize these indices. So we're going to look at a vegetation index, but you might also want to go and look elsewhere in the world and compare what the urban indices or the burn indices or water indices look like. But in this video, let's just look at the vegetation index. You'll notice that it defaults to the normalized difference vegetation index, the NDVI. That's the most common one. But there are some others. There's the enhanced vegetation index, and there's the soil adjusted vegetation index, or just the simple ratio. But let's stick to the NDVI. We're going to keep the same aggregate block, so it's still going to squash everything together using the median. And we're going to have the add map layer, but I'm going to add another map layer. So I can do that either by going to the toolbox and dragging an add map layer block in here, or I can use the right mouse click to get a duplicate. Now in this one, I'm going to choose a single band and it's going to default to NDVI. And I'm going to click on the cogwheel here because the cogwheel allows us to choose the color ramp. And so for NDVI, I'm going to do something like speed, which means that the higher the NDVI, the darker the green it will look. Those options, by the way, on the map layer visualization, I'm going to look in a little bit more detail in a later video. So let's run this and see what we get. So you'll see in our layers here, we've got two sets. We've got our false color image, which is the combination of the near infrared and the red bands. And we've got our NDVI band. The false color band is at the top. And being at the top means that that's the top layer that we see. What I can do is I can either remove that, or I can drag the NDVI block above it so that it's on the top. And you'll see now we've got a legend because the NDVI goes from -1 to +1. But here that's just the range of data that is available, and so that it's set, automatically set the range for the legend. And it goes up to 0.86. So we can see now we can actually start to quantify the areas of vegetation. And you'll notice that the variation here is homogeneous, unlike if we look at our false color image where there is shadowing due to the trees. In our NDVI image, it's much more consistent. We can do this for lots of different areas. And one of the things that we're going to look at in a later video is a time series of NDVI. So how does that NDVI change over time? In the next video, we're going to look a little bit more detail about how we scale these legends and how we visualize things on the map.